Okay, for today we're reviewing for the final. There is a sheet that comes with the final that has got a whole bunch of formulas on it, but I want to start today with some things that you would wish were on that sheet. Okay, so I have a separate document for this that I would call last minute final review. Do you remember in inverse trig where there was only certain things or certain quadrants where, for instance, arctangent lived? Try to rack your brain for where is arctangent allowed. There's also the dead zone and the negative zone. See if you can make that little document for inverse trig. Where was the dead zone? Where was the negative zone? Where answers in that zone had to be negative? A ton of kids got that wrong on the last time you saw it. A ton of kids gave the answer of 7 pi over 7 pi over 3. No, it wasn't that. It was 7 pi over 4. That's what it was. A ton of kids gave that answer. That's an impossible answer on inverse trig. Okay, if you've forgotten this, for inverse trig, let's review it today because it's going to come up. All right, did you remember that inverse tan was from here to here, but it doesn't touch? Who actually had that? That's about a third of you. Arctan, better write it down. Arctangent is only allowed from pi over 2, you would have all known that. To some people would have said 3 pi over 2, but that's wrong. What is this spot down here if it's not 3 pi over 2? Negative pi over 2. When you do an inverse trig, for reasons that would take too long to explain right now, because we had a whole day on it, and I only have a few minutes here, it's from pi over 2 to negative pi over 2. That makes this the negative zone. Any answer that would end up normally have been like 7 pi over 4, it won't be that. It'll be a negative angle. It's like negative pi over 4, for example. Okay, so that's two things that you need to remember about inverse trig. Here's another. Inverse trig. There's only one answer to an inverse trig question. Usually you have two answers. You know, like the answers between 0 and 2 pi, often there's two answers. When you're doing inverse trig, there's only one. I'll remind you why again in a minute. But who remembers what goes across the top here? Arc cos. Very good. That's the same as cosine with a little negative 1, right? You know, like inverse cosine. With the arc in front or the little negative 1 up as a power, either way, that means inverse cosine. Okay, and then there's one last one, and it's sine, and where does it go? Same as tangent, but it touches. Perfect. This is arc sine. All right, that'd be one of those things that'd be really handy to look at, like right before the final. And let me give you an example of one. Here is a arc question. Arc tan of negative 1. You may recall I encouraged kids to write, that's tangent of some angle equals negative 1, but there's restrictions. And you got to remember, again, what that restricted you to. And then you got to remember that tangent's negative, so that restricts you even more until you can only make one triangle, because there's only one answer to inverse trig questions. See if you can figure it out. I'm going to pause for a second. Let you try that. So let's give you a minute to talk to the person next to you. Have you talked to that person? Raise your hand if you had the same thing as that person. Okay, cool. Garrett, what'd you guys have? All right, so you drew the triangle down here. Let's talk about why. So this is where arctan lives, here and here. So this is out and this is out. And tangent's negative, so that means that one's got to be out, because tangent would be positive there. So then tangent is toe up. I'm going to put in two sides. They always give you two sides, whether you know it or not. They're giving you two sides. and it's negative 1 over 1, which makes it negative 1, and this is a 1, and this is the square root of 2. And you should be like, I know that one. It's the 45, 45, 90. But if you said 45, you'd be wrong in 2 counts. Number 1, you should never give degrees anymore. You give radians, so that's pi over 4. But then also, it would be normally a whole bunch of pi over 4s. It's not, it's negative pi over 4. Okay, awesome. Question, comment? All right, so that's inverse trig. Is that the only kind of inverse trig we did? Nope, there's more. Let's do another one like that in inverse trig category. Let's go with sine of the inverse cosine. I'm going to write it this way this time. Of negative root 3 over 2. So if I were you, I always draw triangles for these kinds of things. See if you can draw a triangle, figure out what quadrant you must be in. Remember that it's arc cosine, and therefore it only can live in 2 places. And then it's negative, narrows it down to only 1 place. I'll pause while you give that a shot. So I've been asked my first question from the review sheet, but before I do that, I really ought to answer this question. I will answer your question in a second, but here's this one. Inverse cosine. So I know it has to be between here and here because that's how inverse trig works for cosine. So then I cross off this and I cross off that. And then I see that it's negative. Could it possibly be here? No, because everything's positive in that quadrant. So I hope you knew you were drawing your triangle there. Now, cosine is adjacent over hypotenuse, and I'm recognizing a triangle here. What's across from the 1? 30 degrees. You should memorize that. And then, if that's 30, it's also known as pi over 6, but it's really not pi over 6, or it'd be here. So it's a bunch of pi over 6s. What did you say the answer was? Do you know what that is? 5 pi over 6. Good. Now, I know some of you are like, but I didn't really need that, Mr. Server. I needed sine of that angle. You're right. But this is 5 pi over 6. And then sine of that, you'd end up drawing the same exact triangle. And sine is opposite over hypotenuse. And therefore, it's 1 over 2. Who had that one right? Okay, good. Now, let's look at the first problem of the packet. I've handed out the review packet. It is included on the Schoology page. Numero uno, you're going to want a formula from the formula sheet, which is also included in today's Schoology folder. Garrett, would you read me question number 1 off the packet?
Find the 102nd term of the sequence below, and then it lists 1, 3, 9, 27. 1, 3, 9, 27. Did they tell us whether it was arithmetic or geometric? No, but you can figure it out. Do you get that they are not adding something that's the same each time? So therefore it's not arithmetic. It must be geometric. And if it is geometric, you can find its ratio always by taking the second term divided by the first term. So 3 divided by 1 is 3. That's what you're timesing by each 3. It's geometric with a R value of 3. Now, there's a formula for finding the 102nd term. Jack, would you please look it up on the review sheet that we included? It's on the Schoology page. Have you opened up that file yet? Okay, find it quick. Open up the Schoology folder for today, and inside you're going to see a review, or not a review, what do they call it? Formula sheet. There we go. Find the thing they call formulas sheet. What you're looking for is the geometric formula, because we just established this is geometric with an R value of 3. The geometric formula that not does the sum ones, S means like sum. This is not a sum. So Jack, find me a geometric formula that's not a sum, and you'll probably have it. So U sub n equals, right? Isn't that the one you have? Okay, I always want both sides of the formula. Okay, equals what? I agree. A, just read me the formula as it exists, then we'll put the numbers in it later.
It has an A N.
It says
A sub n?
Yeah.
Okay, keep going.
No, at like the,
Oh, the very beginning, it says A sub n. I'm sorry. All right, we called that U sub n, but the formula is calling it A sub n, and I hope you get A and U are interchangeable. It doesn't have to be a letter U there. Okay, keep going.
A R N
A times R to the
N
Very good. All right, so now as long as we know A and R and N, we can get the answer. Graham, Tyler, would you tell me A?
1.
Yes, it's just the starting value. So 1 times, what is R, Shoba? Yep, it's right there. So 3 to the power of Martin, N minus 1. What is the N we care about? All right, so 102 minus 1. So you were correct when you said 101. 101. So then, if I just knew what 1 times 3, oh, I guess I know that. What is 3 to the 101? Ooh, that's a big number. So I would use your calculator and I would type it out. And I know it's in scientific notation. It has to be. It's so huge. So you have to know that too. Let's say the answer is 2.3 times 10 to the 103rd power or something. They're going to tell you that with a weird little message on your calculator. Would you read me exactly what your calculator says, Cooper?
1.55.
And then does it say E? And then what?
48.
48? All right. So if you wrote that, I feel like you would not be telling me that, like, you don't know what that means. Because E is a completely different thing. It's not, it's 2.718, and that's not really what the calculator's saying. Can you interpret it? 1.55 times 10 to the power of 48. There is your final answer for that first one. And it used a formula that you probably had a hard time remembering. I want to remind you, the formulas that say S sub something, those are for series and they for adding up all the terms. The formulas that say U sub n, or maybe they use A sub n, those are for just a term. So this is what I call a term finder. And this is the sum. Now, I get you're going to have a lot of like rusty memories here, like, I don't remember how to do this. Well, the answer key is posted, and that should help. I'm going to go through a few each day, and that should help. And we have a lot of time to review. So your job for today is to take that review packet that you have in front of you, and you're to do the front and back side of the first page. That's it. Because if we do that today, and we keep doing that each day we have for review, just the front and back of one page. Master just those things, and you'll stay on top of it, and you probably get an A on the final, because you just have to get 75% of the easies and the hards. Okay, so what are we doing for today on the review packet? First page, front and back. Yes?
Can we do it online instead?
Good question. I will allow you to do it as a, but I don't want you to feel like you're like saving a tree, because I've already printed them. So if you have got it in front of you, I encourage you to just do it on paper. Frankly, I think a lot of kids are going to do better if they have the physical packet in front of them than, oh, I got to go find the digital file. I wonder where it is. Okay, but it is, if you really insist on doing it on your iPad, it's fine, but on the day when I ask you to turn them in, you're going to be walking up and showing it to me, okay? Because I don't want to have to go try to find it online. It'll take 10 times as long as if you'd have just done it on paper. So I'm okay with it, but you're going to have to do a little extra work of walking up and showing me your packet. I'll flip through it and grade it at that time. Yes?
Are we going to use the formula sheet on the final?
Yes, the formula sheet is definitely given on the day of the final. We'll give you a printed copy of that. Yes?
Are there gonna be questions where we can't use a calculator?
Nope, the calculator is allowed on the entire final, so you got that going for you. Yes?
And because of that, does that mean, were some questions where we weren't allowed calculators on the other?
You're just allowed them the whole time, and they could or could not be on there. So just, I understand what you're saying. There are some times where we in the past wouldn't have let you use the calculator, but now you have one. So as long as you show your work. See, some kids will use that as an excuse to, well, I didn't show my work because I just did it on the calculator. You better tell me what you did on the calculator that got you the answer.
What I was gonna say is, do we have to take the answer further and put it into the calculator? Because we had different answers when we couldn't use the calculator.
I get what you're saying. Use your calculator since we've given you the calculator. Now, there are times when I would take a not reduced answer that is super complicated. If you said, for example, inverse cosine of, 14 over the square root, 2 times the square root of 108 or whatever, I might take that, but you're running the risk that I might have wanted you to use the calculator to get the final answer. So up in the problem, it'll probably tell you whether you're supposed to give a decimal answer, but I can default to this. You're supposed to always simplify. Now, on your last test, I had told you specifically that I had thought the calculator wasn't allowed. So I would let you leave an answer like this. But technically, that answer is not simplified. So if in the battle between is it simplified and do we allow decimals, if they say that you're supposed to give an exact answer, then this is the answer. If they say that they want a decimal answer, then you'd have to use the calculator. If neither one of those things was written, then it wouldn't be clear, and you'd have to default to, he wants simplified answers. Then I probably better put that into the calculator, because that's not really simplified. Okay. Now let's take your packet, and there's going to be more questions that you guys have on page 1, front and back side. I don't want to do all the problems for you, or you don't have anything to practice. So if you ask me, like, how do you do number 3? I'm not going to do number 3, but I'll do one like number 3. All right? So let's take a minute, and I want you to just look through the front page and front and back side of the first page. Find a few that you want to ask about, and I'll do those in a bit. But right now, I want to stop everything, and I want you to go fill out a survey. Otherwise, it'll never get done. So there's a survey on Schoology. I want everybody to go in and do the survey. I am not required by law to do the survey. Some teachers are asked by the principal, get kids to fill out a survey. I want to talk with you about the results. I am not being asked to do that. I just want to know this for the good of my teaching. I really, really try hard to get a little tiny bit better every year. Not saying I actually do, but I really try to. Okay, so I have learned things from kids' survey answers over the years that are like really significant. Like I've made some serious changes to what I do based on these answers. Okay, so please, sometimes people don't know that they say all the time. Or, just little things that you could tell me that would make my class better. I'll try hard to fix them. All right, so I'm going to pause for a minute. I'd like everybody, I'm just going to walk around, make sure you're actually doing the survey. If you trash me on the survey, it's okay. Just tell me what you really feel and what I can get better on especially. All right, let's do the survey for just like 3-4 minutes. All right, I have a student who's asked me about number 2 on the packet, and it's about sigma notation. And if you feel completely confident that you understand sigma, you can just ignore me. And that's not what I normally say. But if you feel like you got sigma notation down, that's totally cool. All right, so Rhea, if I gave you one that went like this, do you want me to teach you how to write this part? Or do you want me to give you this part and tell you how to make the terms? Do you want me to? The harder thing, I think, is how do you write what goes in there? All right. So let's say I had this 2 plus, let's actually just give a simple, I'll put the pluses, 2 comma 6 comma, I'm going to add 4 each time apparently, 10 comma dot dot dot. How do I get this to be like some variable and some little equation thing that needs to go in there? Well, this is how many terms you have. You always do it from 1 to whatever. Okay, we're not going to make them more complicated than that. We'll always let you start with 1 to whatever you want to end with. Like if I want 4 terms, that's what the last term is. Then this part, you use the A sub n formula off your formulas sheet. This is the term finder. You would think it would be the sum, but it's not. Because this is the way you find your terms. The sum formula is different. All right, so then I did one that was arithmetic because I add 4 each time. So then I would use the arithmetic sum term finder formula, not the S formula, the other one. So then can you tell me what that would be? I think it's A plus, you're going to have to look it up on that sheet.
A plus n minus 1.
Yep. Now, the tricky part is you want to fill in everything but the n. You leave the n in there because you need a variable in there. All right, so then A is the amount that you start with, which is 2 in this case. So I'm going to erase the A and put a 2. And then I'm going to erase the D, because that's the common difference, and that would be a 4. And that would have been an okay answer. Or you could multiply it all the way out and say 2 plus 4n minus 4. Simplify it down even further. 4n minus 2. And I would have accepted both of the things in the black circles. Either that or that would have been an okay thing to put there that finds terms. All right. Good question. All right, I want to give you some uninterrupted work time, so the rest of the time, just work on the first and second page of the packet. You can always ask me more questions tomorrow, and that's all I have for you for today.
Posting, it takes like